Hello everyone, in this video I am going to explain about ballistic galvanometer. It is very important question in second year third sem BSc Physics. Moving coil ballistic galvanometer is a specially designed galvanometer suitable for measuring charge, which is displaced by a varying current of short duration such as charging and discharging of a capacitor. This is the definition for ballistic galvanometer. Working principle of ballistic galvanometer. Before knowing this, we have to know about its construction. So, it consists of a rectangular coil PQRS. This is a diagram for ballistic galvanometer. When a current is passing through the coil of the ballistic galvanometer, then it rotates. It rotates in the magnetic field and deflects of the coil is proportional to the quantity of the charge passing through it. Hence, the ballistic galvanometer measures quantity of the charge. We have learned about its working principle, so now let us learn about its construction. So it consists of a rectangular coil P, Q, R and S of a copper wire which is wound around a non-conducting frame of a galvanometer. So this coil is suspended by means of a prosperous bronze wire between the poles of horseshoe magnet N and S. So for increasing of magnetic flux, the iron core is placed within the coil. So the lower position of the coil is connected with the spring to provide a restoring torque. So here the spring provides the restoring torque. So when a charge is passes to the galvanometer, the coil starts rotating and gets an impulse. Impulse means a force that starts a body into motion. Okay, the impulse of this coil is proportional to the charge passes through it. So the actual reading of the galvanometer achieved by using a coil having a higher moment of inertia. So the important thing is that the coil having the high moment of inertia, then the oscillations are large and we get the accurate reading. So this reading can be measured by using a scale or a lamp. Now let us learn about its theory. Remember I, B, A and I stands for current, B is magnetic field induction, N is number of coils and A is the area of coil. So the torque acting on the coil is given by torque is equals to I ban, IBAN. Keep this as our equation 1, and this torque acting for an infinitesimal time dt gives an angular impulse. So we can write angular impulse is equals to T dt is I B A N dt. Keep this as our equation 2. So if the current passes to the coil for t seconds, then we can write it as total angular impulse is equals to 0 to t I B A N dt. So separate both of them. We can write it as I B A N dt and 0 to t I dt. So we get this total angular impulse as B A N Q. Keep this as our equation 3. Now here this Q be the total charge passes to the coil. We know that the total angular momentum is equal to the change of angular momentum. We can write it as B A N Q is equals to I omega. Keep this as our equation 4. Now we got 4 equations. So in final position, Ke of the coil is 0 and it initially has half I omega naught square. This is the energy used during the work in twisting the suspension from between the initial to the final positions. So now let C be the restoring couple per unit twist. So then it will become as, so now the total work done in twisting the suspension to theta 1 is given by 0 to theta 1 C theta d theta is equals to half C theta 1 2. So we know that work done in twisting is equal to change in KE, kinetic energy, will be given as half C theta 1 square is equals to half I omega square. If we cancel these two, we get I omega square is equals to C theta 1 square. This will be our fifth equation. So the time period of the coil will be taken as T is equals to 2 pi I by C. If now do the squaring on both sides, we get T square is equals to 4 pi square I by C. We can write it as I is equals to C theta square by 4 pi square. This will be our equation number 6 by taking this 4 pi this side. Okay, now from equation 5, multiply with I, then we get I square omega square is equals to I C theta 1 square, I square omega square is equals to C square theta 1 square by 4 pi square. So if we remove this all squares, we get I omega is equals to C theta 1 by 2 pi. This will be our equation 7. Now from equation 4 and 7, take this equation 4 and 7, we can write BA and Q is equals to C theta 1 by 2 pi. Now take this one this side, Q is equals to C theta 1 by 2 pi into BAN. This will be our equation number 4, and the charge passed to the galvanometer is proportional to the angular deflection theta 1. We can write it as Q is equals to K into theta 1. This will be our equation number 9. So here this K is T by 2 pi. We can write it as K is equals to T by 2 pi into C by BAN. This is the galvanometer constant. And it is also called as the current reduction factor or constant of this galvanometer. This is about ballistic galvanometer.